Hi guys, welcome to N3 lessons, and today we're going to be doing electrotechnology N3, and the topic is direct current machines. Okay guys, talking about direct current machines, we only have direct current machines includes only of two machines, which is two machines, which is a generator and a motor. It is a generator and a motor. So a generator changes mechanical energy to electrical energy, while motor changes electrical energy into mechanical energy. Remember that direct machines include of two machines, which is generator and a motor. Generator convert mechanical energy into electrical energy, and motor convert electrical energy into mechanical energy. Okay guys, talking about direct machines in N3, you're going to have to know about the functions of a direct machine. This is the simple form of a direct machine. Okay guys, the direct machine include of a yoke. This is a yoke. A yoke is this structure, the outer structure. What is the function of the yoke? The function of a yoke, first function of the yoke is for mechanical support, to support everything that is inside. It's for mechanical support. And the second function of a yoke is for mechanical protection. The first one is mechanical support of the field system. Know that mechanical support of the field system, and the second one is mechanical protection of the whole system. Mechanical support of the field system, mechanical protection of the whole system, and last but not least, the function of a yoke is to let me just trace it. The function of the yoke is to carry the magnetic flux from poles. The first one is mechanical support of the field system, the second one mechanical protection, and the third one is to carry the magnetic flux from the pole. Second one, this is the first one. Second one, we have these things, we call them field poles. It's this thing, the field poles. What is the function of the field poles? You see here on this field poles, we have this thing. We have a wire here, we call it a coil. This thing that I drew here, it's a coil on it. So the first function of the field pole is to hold the field coil in position. Is to hold the field coil in position, and the second one is to improve electrical magnetic field. The first one is to hold the field coil in position, and the second one is to improve electrical magnetic field. And here we have this. We have this thing on top. We call it a second. What do you call it? Number 3. This thing, we call it a pole shoe. We call it a pole shoe. And what is a pole shoe? What is the function of a pole shoe? The first pole shoe only include of one function, and its function is to evenly distribute the magnetic flux. Evenly distribute magnetic flux. Is to evenly distribute magnetic flux through the air gap from stator to rotor. Talking about stator and rotor, stator means it is stationary. Stator means it is stationary, and rotor means it is moving. Through this simple form of direct current machine. Direct current machine include of this circle, a yoke. A yoke is stator, it is stationary, and inside we have this dot or a circle which represent armature assembly, which is a rotor. Rotor is those ones that moves. That part that moves, we call it a rotor, and a part that is stationary, we call it a stator. So pole shoe is to evenly distribute magnetic flux through the air gap. This is the air gap from stator to rotor. Okay guys, and now let's move on to this. I'll say it's number 4. These things, number 4. These things, you see these things, we call it a field coil. What is the function of a field coil? The function of a field coil is to produce main magnetic flux. The function of the field coil is to produce the main magnetic flux. And then last but not least, we have, okay, it's not the last one. We have this space. This space, we call it air gaps. Air gaps. Those spaces, we call them air gaps. What is the function of air gaps? We have 2 air gaps. We have 2 air gaps. The first one is small air gap, and the second one is large air gap. The small air gap is to maintain electrical magnetic field. The function of the small air gap is to maintain magnetic field. Remember, the small one is to maintain magnetic field. I'm not going to write it all. Maintain magnetic field. And the large air gap is to avoid contact between rotor and stator. The last one is to avoid contact between rotor and stator. And last but not least, we have the assembly. This one. This was number 5. We have the assembly. Number 5. We call it armature. Okay, I'm sorry. Let me just write it here. Number 5. We have this dot that represent armature assembly or assemble. Yeah, armature assembly or armature assemble. This dot that represent the armature assemble. So what is the function of the armature assemble? When we are dealing with the armature assembly, we're talking about the rotor part, which means the part that is moving, right? Okay guys, so when we are dealing with the armature assembly, know that it is a moving part. What is the function of this moving part? Is to provide torque. Torque is a movement, guys. Torque is a movement. It is they might ask you to define it. A torque, it is a twisting or rotation which causes movement or results in movement. It is a twisting or rotation which results in angular motion or movement. Remember, to provide torque. And within this thing, the armature assemble. The armature assemble is a part, guys. I will show you something. Guys, this is armature assemble. Armature assemble include of armature core, commutator, bearing, cooling fan, and a shaft. You see, it is that dot. That dot represent this armature assemble. We call it assemble because it is assembled. Assembly, you guys know what assemble means. It means that it is a one object that include of many parts. You see, we have shaft, cooling fan, armature core, commutator, and bearings. So while we were still talking about the armature assembly, you guys already saw that it is one part which include of many parts. That's why we call it armature assembly. And then on this part, we have armature core. On this part, I'll write it here, number 6. Armature. Hey guys. We have armature core. What is the function of armature core? The function of the armature core is to minimize. Just gonna write minimize eddies current law. No, not current, not a law. Please don't include law. Is to minimize eddy current. Sorry. Eddy. Remember, eddy current is to minimize eddy current. And then there also we have, see, yes, I still have space. And then there again we have a armature winding. Number 7. Armature windings. We can call them windings or we can call them conductors. Armature windings and armature core or armature conductors. Armature, we have 2 types again here. We have wave winding and we have lap winding. Remember, we have wave winding and we also have lap winding. Okay guys, I said we have lap winding and we also have wave winding, right? Those are windings. We in the future will call them conductors. So for lap winding consists of, okay, let me talk about its characteristics first. We call it a perpendicular, parallel, sorry, parallel winding, or overlapping. It is parallel or overlapping. I will show you why we say that it is parallel or overlapping, while wave, it's in series. It's in series. This one is parallel or overlapping. This one is in series. The function of this parallel winding or overlapping, which is called the lap winding, is to move high current, because it includes of high current and low voltage. It is to move that high current, see, to distribute that high current, and it also includes of low voltage, while this one, which is in series, only includes of two brushes. It only includes of two brushes, and its function, you see, is to maintain that high voltage, while it also has low to medium current. Those are the differences. For a lap, it is parallel. This one, for wave, it is in series. For lap has high current and low voltages, and wave has high voltage to low current, low to medium current, guys. And now I want to show you guys the drawings, because the drawings are very important of them. Here are the drawings, guys. The lap winding and the wave winding. Know how to draw this. It's very important for the exams. And while you're still on it, let's move to commutator. Those guys, the armature core, armature winding, the armature windings and commutator, they are part of the rotor, the moving parts, So commutator is a hard drawn wedge shaped. It's a hard drawn wedge shape insulated in copper or covered in copper. Covered in copper and then insulated with mica. It is a hard drawn wedge shape which is covered in copper and insulated with mica. Okay guys, it is very hard. It is wedge shape and it's covered in copper and insulated with mica. Okay guys, why is it insulated in mica? Why is it insulated in mica? It is insulated with mica because mica can withstand high temperature. I'm just gonna do this. Mica can withstand high temperature, and mica is hard and robust, doesn't break easily, withstand high temperature, and hard and robust. Okay guys, why is it wedged shape? Commutator is wedged shape because it has to stay in position. It has to stay in position during centrifugal force. It has to stay in shape. It has to stay in position during centrifugal force. That's why it is wedged shape. Okay guys, and yeah, while we're still on it, let's talk about the functions of commutator. What are the functions of commutator? Function number 1, the commutator allows electrical energy. It allows electrical energy to flow. It allows electrical energy to flow from strata, you see, it allows electrical energy to flow within strata and rotor by the means of brushes. Allows electrical energy or electrical connection, can say connection, allows electrical energy or electrical connection to flow from strata to rotor by means of brushes. By means of brushes. Sorry guys, my handwriting is not that good, but you can understand what I'm trying to say. It allows electrical energy or connection to flow from strata to rotor by means of brushes. And then again, it is to collect current. It is also to collect current. So let me just do this. It is to collect current. Collect current from armature conductors. See, from lap and wave windings is to collect current from armature conductors. Guys, remember, is bigger. Collect current from armature conductors. That is also part of, functions of commutator. And it is also to convert AC current into DC current. Convert AC current to DC current. I'm sorry about that. It is to convert AC current to DC current. Okay guys, let me read all of them to you. The functions of commutator. It is to allow electrical connection to flow from strata to rotor by means of brushes. And then it is to collect current from armature conductors. And then last but not least is to convert AC current to DC current. And now we're going to talk about bearings. Part of rotor 2. What is the function of bearings? Okay, we have 2 listed ones on my textbook. It's baller bearing and roller bearing. Its function is to minimize friction, guys. It is to minimize friction. Yes, it's to, yes. Okay, guys. Yes. And now, remember, guys, the 2 types, of listed bearings. They might ask you to name them. I know baller and roller bearing, and its function is to minimize friction. And then last one, brushes. Remember when we talked about commutator, we said it allows electrical energy or connection to flow from stator to rotor by means of brushes. Remember, by means of brushes. That means the function of brushes is to allow electrical connection, connection from stator, not from between stator and rotor of armature. See, is to allow electrical connection between stator and rotor of armature. Okay, guys, and we have different types of brushes. The function is to allow electrical connection between stator and rotation of armature. You see? Yeah. Okay, guys, I think I made a mistake here. The function of brushes is to allow electrical connection between stator and the rotating commutator. Guys, remember here it's commutator. I think my pen is finished. Commutator. Commutator, guys, it's commutator. And then we have different types of brushes. Okay, guys, we have carbon brush, which is popularly used or mostly used. They mostly use carbon. Why do they use carbon? Carbon is very weak when it comes to, providing electricity. It's very weak, but it can withstand high temperatures. They use it because it can withstand high temperatures, and they also use it because carbon dust act as a lubricant to commutator, which helps commutator to supply electricity easily. It withstand high temperatures, and carbon dust act as a lubricant to commutator. Okay, guys, and this lubricant also polish the commutator. it helps to polish the commutator. And then we have graphite. This graphite, guys, it is very weak. First thing, know that it is very weak. Graphite is very weak, and again, yeah, it is very weak. The only reason why they use it is because during its operation, it doesn't create noise, so it is noiseless. See, it is not loud. That's why they use it. They use it because it is not loud. And then, guys, they also use, I'm sorry, I'm not gonna write everything. Others I'm just gonna tell you, okay, guys. And then they also use copper graphite. Copper graphite. Hey, you see, let me just do this. Copper graphite. Write them down there. Why graphite? Because it is noiseless. Why copper? So that it can transport large electricity or large current. See, for transportation of larger electricity, you see, or current. See, yes, for transportation of larger current, or you can say it can carry large current, and it is also noiseless because, yeah, it is graphite. Okay, guys, and we also have electrographite. Electrographite also, guys, electrographite also, by its name you can tell it is also to carry a large current. Yes, and we end there our lesson. And there, guys, thank you, and please tune in more to N3 lessons. So part 2 I will continue with direct machines.